Welcome to another video of Embedded Blockchain. If you are new to this channel, I hope you enjoy our videos and don't forget to hit the like button and the subscribe button. If you are not new to this channel, then welcome back and don't forget to hit the like button. In this video, you will learn about computer architecture. You will learn what is inside a computer and the parts that make it work. The most basic computer system consists of a memory, CPU, and a clock. Program memory, this is where the program is stored. That is, the instructions or the CPU. CPU is the central processor unit. This is the block that processes the instructions and basically executes the program that is stored in memory. Clock. This is needed to tell the CPU to execute the next instruction to keep the whole system synchronized. The clock is very important since it determines the speed at which the instruction will be executed. You've probably heard a lot about gigahertz when you buy a laptop. This is the speed of the computer basically. The higher the hertz, the faster the computer. A microcontroller must be programmed. This means that it must be provided with a series of instructions to be followed. These instructions must be stored in ROM memory. The CPU reads the instructions from memory. It does this by using the clock signal. Every pulse in the clock tells the CPU to read an instruction. The CPU has a special register called program counter, abbreviated PC. This register indicates where the next instruction is stored. In order to read data from memory, the computer needs a data bus. This is the connection between CPU and memory. Each place in memory is numbered for illustration purposes. We number them from 0 to 3 in the memory block. The computer uses two buses called data bus and address bus. The data bus carries the data stored in memory to the CPU and also from the CPU to the memory. The address bus carries the address where the CPU has to read from memory. The memory is divided in two categories: volatile memory and non-volatile memory. Volatile memory, usually called RAM, is where the temporary data, such as variables, is stored. Non-volatile memory, usually called ROM, is where the program you wrote is stored. It is in ROM where the instructions are stored. Segment of memory is the peripheral or special registers. Microcontrollers usually have peripherals such as analog to digital converters, inputs, outputs, etc. All these segments of memory are numbered in a continuous manner, as if they are one memory for the computer, although they are different. For example, if we look at the MSP430 family, in the datasheet we can find the memory map. We can see it is numbered from 0, starting at the bottom. We can find the special function register, the peripherals, then RAM, flash or ROM, interrupt vector table. This is how Texas Instruments designed these microcontrollers. Another example is the TM4C123 family. We can see in the memory map it starts from 0 at the top. It begins with flash or ROM memory, then RAM, then input-output ports. Each microcontroller is different. Depending on the manufacturer will be the design of the memory. One thing to notice is that all addresses in memory are continuous, and you can access peripherals the same way you access ROM or flash. Each port has a specific address. There are two main architecture designs. One of them is the Harbor architecture, which has two separate buses, one for the data and one for the instructions. Since Harbor architecture has separate memory spaces for instructions and data, it allows for parallel and simultaneous access to both memory spaces, which leads to faster and more efficient data access. However, the use of separate memory spaces for instructions and data in Harbor architecture adds to the complexity of the processor design and can increase the cost of manufacturing. Another example is the von Neumann architecture. The design of a von Neumann architecture is simpler than the more modern Harbor architecture. The design of a von Neumann architecture has one bus for data and one bus for address. Both data and instruction are handled by the same bus, making it more simplistic than Harbor architecture. One drawback is that it takes longer to execute one instruction because the CPU first has to read the instruction, then fetch the data the instruction is requesting. This process takes more clock cycles.